Veerabhadran Ramanathan is back on the streets of his native India.
We're in the Surya village, the town next to the village.
When the professor of atmospheric and climate sciences at Scripps Institution of Oceanography at UC San Diego videotaped this visit to the state of Uttar Pradesh in 2009, he was at the beginning stage of the most personal field campaign of his 40-year career. Prior to his visit, Ramanathan had amassed data over 35 years on the effects of so-called short-lived climate pollutants like black carbon, methane, HFCs, and ozone. These compounds have a powerful effect on climate, but many typically remain in the atmosphere only for a few months or less. Control of these agents has emerged as a promising short-term tool to slow the pace of global warming, a relatively easy way to solve a significant global problem. In February 2012, the United States, in a coalition with the UN Environment Programme, Sweden, Canada, and Bangladesh, among others, announced the formation of a multinational initiative to mitigate the effects of these pollutants. Chief among them is black carbon soot, an aerosol that warms and darkens the atmosphere. For more than 3 billion people in the developing world with no access to fossil fuels, it is the byproduct created when they burn the fuels available to them: wood, dung, and crop residues.
Originally, it started as a joint project with Professor Paul Crutzen in the 1990s. We've discovered this vast plumes of pollution cloud. We call them brown clouds, atmospheric brown clouds, or ABCs. Later, I developed this unmanned aircraft with my students and scientists in my group. And the deeper we penetrated these clouds with the UAVs, it became clear to us that these brown clouds, particularly black carbon, was causing a number of problems we had not even dreamt possible. Roughly half the pollution, black carbon, was coming from residential combustion of biomass fuels, basically using firewood and cow dung for cooking and heating. There are over about 600 million in South Asia alone. Worldwide, there are about 3 billion cook with these biomass.
It is this problem that has brought Ramanathan back to India to try something new. He has started Project Surya, named from the Sanskrit word for sun. Surya is a science experiment to measure how the atmosphere responds to the removal of smoke and soot particles that tint the sky in India. It is also a demonstration of how people in many developing countries could live healthier lives while slowing the pace of the climate change that threatens the entire world. Ramanathan has enlisted the help of many of these people to demonstrate what happens when black carbon, a greenhouse agent released in smoke and diesel exhaust, is eliminated from the atmosphere. In this corner of India, the change comes about by giving people a new way to make their meals.
It's something I think many of us as scientists would like to believe, that as we mature and go forward, that some of our work might be useful in this societal domain. And I think in Ram's case, that is certainly true.
There are about 600 million people in rural India who are dependent on biomass and biofuel. And rural energy has been often even internationally a neglected area. Particularly cooking technologies has been neglected, both by donors, by scientific community. And Surya draws the attention of global community as well as scientific community on looking at ways to improve the current law.
Traditional stoves use wood, cow dung, or grasses as fuel, but do not burn efficiently because of the high moisture content of the fuels. Women must constantly stoke their fires by blowing on the burning material. Improved cook stoves burn more efficiently. They only need 1/3 the amount of wood. Small battery-operated fans force air into the stoves to aid combustion. Traditional cook stoves burn with an efficiency of 10%. Improved cook stoves burn with an efficiency of 35% or even more. In October 2009, after more than 2 years of gathering support and financing, Ramanathan and his collaborators from India's Energy and Resource Institute, or TERI, distributed efficient low-emission cookers and solar-powered lanterns to some 500 households in an area just south of the Indian city of Lucknow. When TERI filmed the progress of Project Surya in 2011, villagers had just begun trying out new cookers that burned their usual fuels in a more efficient way. Surya researchers take measurements of the black carbon emissions in individual households, and the residents also make their own reports. A technological first in Project Surya is the use of cell phones as data collectors. Ramanathan has enlisted the help of his daughter Nitya, a computer scientist at UCLA and president of NextLeaf Analytics. Together, they have developed low-cost data collection methods that villagers can use without the need for extensive training.
We really looked to develop a very low-cost, small footprint technology. And as the process developed, what evolved was actually that the technologies also had a very potential direct benefit for the women. The temperature sensor on the stove potentially makes it possible for women to directly connect with carbon markets. So this means that a woman in a village could potentially be uploading data directly to a carbon market and receiving financial benefit for her switch to an improved stove. With the second technology, what happened was women would see the filters that were exposed in the samplers and started having a very sort of direct, visceral response to seeing the darkness of the filter and really understanding viscerally how the particulates in the air might be impacting themselves and their families and children's health.
Ramanathan hopes that the legion of clean-burning stoves will grow from hundreds to millions across South Asia. Many obstacles remain, though. The scientists are overseeing the supply of cookers to people who can scarcely afford them. And once the cookers are introduced, the researchers must also manage the perception of the stoves by their intended users. In fact, one component of Project Surya is a sociological analysis of what motivates people to accept new ways of doing things into their everyday lives. That feedback will guide the rollout of cookers as the project goes on.
We now know the nature of the pollution, and we know how to solve that problem technologically. There is still the social side of it, having women want to use this, not because we are asking them to, but they want to. So we are not there yet. We are now starting to do this pilot phase in 4 other countries: Bangladesh, Nepal, Bhutan, and Kenya. So these are vastly different cultures and vastly different cooking practices. So what we are hoping to gain by doing it in this 4 other countries is that we'll have enough knowledge base to develop a solution or solutions which could be then scaled up.
Ramanathan understands the challenges, but remains optimistic.
As a teenager, I've seen my grandmother cook the most delicious meals with this biomass combustion on traditional mud stalls. And I also seen how after an hour or 2 of cooking, she'll suffer with racking cough. So I could relate when I saw epidemiologists saying this is causing over 500,000 deaths in India alone. So to me, this was a fantastic opportunity to address a societal problem with the realization if I solve my grandmother's problem, I solve the climate problem.